So, good morning, good afternoon to those of you who are attending. Thank you very much. Appreciate it on this Friday, either morning or afternoon. Today, we'll be talking about the optimization of rubber to metal bonded coatings, and we'll go ahead and move forward to the presenters. So, let's talk about our presenters today. Pablo Morales. Pablo has more than 18 years of automotive experience on rubber to metal bonded components, from engineering to operations. And then myself, Troy Oscar, I have more than 20 years of automotive experience, mostly in NVH, as well as other opportunities, working in roles from engineering as well as commercial leadership. So we'll be focusing on bonded processes for rubber to metal, as we talked about, and really talking about the process flow from the beginning of preparation of the materials, primer and adhesives, to the application. And if you'd also like to go to our Surface Engineering Academy, you can touch on a little bit about our cleaning processes, as well as the application of surface modifications such as zinc phosphate and some of the other phosphates that we offer. So during the webinar, we'll be talking about assessing the component requirements and determining the right process for the job. So in many cases, we'll be looking at the types of parts that we're working on, and we'll offer chain on edge or round table, roll coater, dip spin, a dip drain, tumble spray, or hand spray. And many of those applications really depend on the type of part, what the customer wants from a spray or application standpoint, coverage standpoint. And so really it's important, and we'll walk through this, but it's important that we work together with our customers to ensure that we have the best part and component available for your bonding needs. We'll touch on the Surface Engineering Academy, and then we'll also have a question and answer session. And then after the webinar, we'll send out a survey and ask for your opinion on how the webinar went, as well as any other questions or maybe items that you have that you'd like to see further. So let's go ahead and get started on the next process. So from a process standpoint, let's talk about how we apply rubber to metal bonded materials from a mixing, dilution, primer, and application standpoint, as well as adhesive. So Pablo, do you want to go ahead and touch on this?
Okay, yeah, thank you, Troy. So basically what we are looking here, it's what we need to do in order to apply rubber bonding system into a substrate. So first of all, you have to have the bonding system preparation, which consists in mixing before applying any bonding agents, the chemicals required to get mixed to incorporate the solids. You know, there's a variety of type of bonding systems and presentations. They come from 1 gallon buckets, 5 gallon buckets, 55-gallon drums, or even totes. So depending on the size and the type of bonding system that you have to follow the recommendations and perfectly mix those. The time for mixing could go from 1 hour, depending on the size of the bucket, up to 8-12 hours. And you need to make sure it's all the solids are completely mixed and into the make sure to have it to start with the process. The second step will be the dilution, and the dilution will also vary depending on the type of bonding system that you're going to apply, and also the type of process that you're going to use after. You know, you don't have the same dilution for a spraying process than for a dipping process, and we're going to dive a little bit into the process next. But those are very, very important items that you need to make sure before applying a bonding system into a surface. Then there's the adhesive application itself. This is what the webinar is going to be teaching us in the next few slides. Most of the bonding system consists on two system application, which is a primer and adhesive, but there's also different adhesives that also perform well with no primer. But most common you will gonna find a primer and adhesive application. So first of all, you have to apply the primer. Must you obviously you will have to have a clean surface, and there's information, as Troy mentioned, on other videos on our webpage that you can assist. So once the surface is completely clean, you apply the primer. And then a very important thing here is once you apply the primer, you need to make sure it's completely dry, and if all the solvents are evaporated from the primer. It's very, very important to have this step completed, because if you don't dry completely and you apply the top coat on top of the primer, that will create you some issues while molding the parts. Issues will be similar to bubbles and blisters on your molding, because you didn't let all those solvents escape or evaporate, and they get trapped into the between the primer and the top coat. Once you have a completely dry surface and all the solvents are evaporated, you proceed to the adhesive application. So the adhesive application will be pretty similar to the primer, and then after that you will dry again the surface before manipulating the surface, so you don't get marks or touch on that surface. So that's extremely important. So the drying in both cases is very important, but on the primer side, also the solvent evaporation is what we're looking for.
So Pablo, as we talk about this process, we know that this is a very high level look at everything, but it's critical that each one of these steps is done properly, because as we know, our parts are going into bushings and mounts and other types of products where they're molded, and it's absolutely critical that we follow these steps to the T and make sure that we have a good process, a good part that we're sending to our customers, so then when they mold those parts into their components, that they don't have any issues, and they can count on the processor to make sure that these parts are good.
Yeah, that is correct, and that's why we wanted to start with this slide. It's very, very important to follow these steps and make sure you're following the guidelines on the bonding system that you're applying in order to have successful bonding after molding.
Okay, so let's touch on the first slide that we have regarding our bonding process. And that first slide is chain on edge and round table. Really, these are very similar, and Pablo, you can touch on the differences between a round table and a chain on edge. But I think, as you can see here, really you get a good idea of what we're talking about. So Pablo, do you want to go ahead and start?
Yeah, obviously. Thank you very much, Troy. The chain on edge and round table, those are their commercial names, but it's basically a spray application. So this is the most common use process that we have, because it gives you the ability to coat almost any single type of part that you have. So as you can see in the pictures and videos down there, you can spray the inside diameter of a can or the outside diameter, depending on what you're looking for. Also, it gives you the ability to mask certain areas that you don't want to get covered, and all that depends on the tooling design that you're looking for. So the benefits on a chain on edge is that it's very versatile. It has very high capacity for large volumes and the masking capability. Really, the difference between a chain on edge and a round table is the size of the chain and how many parts you're going to run. So you're going to use more chain on edge for large volumes. We're talking 350 stations versus 50 stations on a round table. So depending on how big is the volume annually, you pick either or, but the transfer efficiency and the surface application is going to be pretty much the same.
So from a chain on edge standpoint, if we talk about transfer efficiency, how would we compare chain on edge versus some of the other things that we'll talk about?
Oh, chain on edge is obviously not the best transfer efficiency. You can see that there's going to be, it could go from 60% transfer efficiency, but in some cases it could go down to 40%. It all depends on the size and shape of the parts. There are parts that are hollow, and then you will waste a lot of material in those type of parts. But truly, there's no other way to coating them, basically. So compared to a roller coat or a dip spin, those are gonna be more in the 90 percentile transfer efficiency. So those are better methods, but unfortunately, as we're gonna see in the following slides, not all parts are suitable for those processes.
Right, exactly. And so this is really the most versatile process that we have overall. All right, so let's touch on the next slide. The next slide really focuses on roll coater applications. And as you mentioned, transfer efficiency is very good. This process mainly focuses on round parts though, and so I'm sure you'll get into that a little bit.
Sure. The roller coater, as its name calls, you apply the bonding system via transfer from rollers. So obviously you don't have the flexibility of applying to any type of shape and size. So what we're looking is perfectly cylindrical parts that you need to coat on the outside diameter, as you can see on the top video. And then on the bottom one, we are applying also on perfectly cylindrical parts on the inside diameter. So this is going to give you the best transfer efficiency. The process itself also has stations for drying as the process goes. You can regulate the time of coating and the time of inside the furnace for drying. It has a lot of benefits. Obviously, we talk about the transfer efficiency being one of the best, but also gives you flexibility. The flexibility here is for different size parts. Usually for an inner metal, we can go up to 100 millimeters in length. The diameter can vary, and you can still coat them. The retooling time is minimum because usually you have the same tool set for almost every single part that you run. The only changeover that you can probably lose a little time there is when you are switching adhesives. You need to be sure you work the line and you clean the rollers before applying a different type of adhesive. You're going to have a dry film thickness reduction in variation because this is going to be a more steady process than even spray. Sprays, as you saw in the previous videos, parts tend to move a little bit. There's a play between the tooling and the speed of the line, and it creates you some small variations. So these two processes in roller coater will reduce that. And also another of the benefits is that you have full automation here. The parts are automatically loaded and unloaded, so there's no manipulation for an operator. The operator just need to make sure the parts or the hopper is completely loaded with parts, no touching the parts at all, and the parts will get dumped into a container at the end.
Yeah, so from a labor standpoint, this process really works out well.
Yes, again, this is probably one of our best processes. The only downside is that not all parts are perfectly cylindrical parts.
Okay, perfect. So let's talk a little bit about dip drain then, which is a pretty significant move away from chain on edge or roller coater when we talk about processing of parts. In these types of parts, really the benefit is you're completing or coating the entire part, whereas chain on edge or roll coater have very specific areas that we have to coat. So Pablo, why don't you talk about dip drain for a second?
That's correct. Well, the dip drain application, as you can see in the video, consists on just dipping the parts into the bonding system. Again, you need to prepare the dilution for the type of part and the type of film thickness that you want to achieve. This process will give you 85 to 90% transfer efficiency. It's a little bit more labor intensive than dip spin, which is something that we're going to see next, because this consists, you need to have operators loading and unloading the parts into the hooks or the racks that you design for the part. It works very well on parts that can be completely submerged in coating. Some obviously at the beginning of every project we discuss with our customers if this is a possibility, because this could be better transfer efficiency as mentioned. And if the parts allows you, and it's going to be completely encapsulated with rubber in most of the cases, this is definitely a pretty good option for you, and you don't have to waste, or you don't have to overpay for the low transfer efficiency that we discussed on chain and edge. So it gives you flexibility for parts that are going to be that are allowed to be completely deep. It has better transfer efficiency than spraying, and it has a very high capacity for high volumes.
So you mentioned flexibility. There's also the same flexibility from a tooling standpoint where we can use similar tooling for different parts. I think that's important to note. The other thing that I'd like to touch on is the criticality of dimensional requirements when we're talking about parts like this. Obviously, it's important that we make sure that we put the right primer and the right adhesive thicknesses on our parts. But can you talk about this and the variability between a dip drain and, say, chain on edge versus roll coater?
The variability on type part, on size?
Yes.
Okay, well, the parts are going to be pretty much similar in shape and size. Obviously, as big as the tanks are, you can put probably larger parts definitely on a deep drain than what you can do on a chain on edge. We're talking probably 5 inches length on this type of process. One other item that is really important is there's a way of potentially masking some parts. If parts are not allowed to be completely covered, you can design a tool set. We have a couple of them in Mexico right now that we just cover partially what the customer is looking for. You need to make sure your level on the tank is at the right height, and obviously the tooling design helps you to cover the portion that you don't want to cover.
Okay, well, thank you very much, Pablo. All right, next is dip spin. So let's touch on dip spin and maybe the differences between dip spin and what we see with dip drain.
Yeah, well, deep spin is it's another deep process which has a pretty good efficiency, transfer efficiency over the 80s. But this is a process that it's going to be better suited for smaller parts. The process consists on putting the parts into a mesh basket. And once the parts are in the basket, you put them through the tank, dip them into the solution, then remove them, and then spin it to remove the excess. Depending on what type of film thickness you're trying to achieve, you dilute you set the dilution on the concentration and also the dipping and spinning times. After all these processes made, parts will drop into a conveyor oven to get dry. Obviously, one of the downsides here, if you want to apply primer, first it has to be on one cycle, and then a second or third cycle for applying the top coat. This is a pretty good process for O-rings, nails, clips, bolts, spring clamp fasteners. It's a pretty good process for those type of smaller parts, and has flexibility, a better transfer efficiency, and high capacity for those smaller parts.
As we talk about dip spin, the nice feature with dip spin though is you can do many different types of parts other than primer and adhesive type bonded components, and so that's important to note. But what we do is we separate those parts so they're not run on the same machines, because some of those parts need to have high heat cycles so that those chemicals dry with a very high heat temperature. So Pablo, do you want to talk a little bit about the differences there?
Yeah, this method is well known in the industry, especially for zinc plate coatings, moly coats, which are anti-friction coatings, also Teflons, and those are obviously run in a different machine, because obviously to avoid contamination. But as you mentioned, Troy, the cure times that these processes require are high temperature ones. We're talking 450 Fahrenheit compared to 90 Fahrenheit, 100 Fahrenheit for the bonding system. So we definitely run those in different lines and different processes.
Okay, great. So moving forward, let's touch on tumble spray a bit, Pablo.
Yeah, well, tumble spray, as it names calls, and as you can see in the video, is just putting the small parts into a tumble, and then instead of dipping them, you spray them. This is a good alternative for parts that our customer is looking to have a better surface finish than the dip spin. Dip spin, one of the downsides is that as you put a lot of parts, it's a bulk process, there's going to be a lot of touch parts in between, touch marks, and parts are going to get stuck together in some cases depending on their shape. But the tumble spray will allow you to have a better surface. One of the things we do at Pioneer is we create hybrid processes where we use the dip spin to get the buildup of the film thickness that we're looking for, and then we touch them up on a tumble spray in order to create that better surface that our customers are looking for. Again, this is depending on what type of process you want, what type of molding you're going to get, what type of potential defects your molding process is going to allow you to have. But the tumble spray process by itself, it can create the primer application and top coat application required in one cycle. That cycle usually takes around 45 minutes, depending on how much film thickness you want to apply. But the capability is that they can dry the parts while they're inside of the tumble, and you can have the parts fully processed on tumble spray at the end. So it gives you flexibility also on small parts, very high capacity. We're talking approximately 100 pounds per load, and it will give you a smoother surface and less defects than the dip spin.
So the nice thing about the dip spin and the tumble spray is the need for tooling. We don't necessarily need tooling in these cases. However, we have to be careful about what types of parts we're running.
That's sure. Again, this is a those two are cost effective compared to obviously spraying. You don't need tooling requirements, but again, you on the downside, there's going to be a lot of touch marks. The film thickness is not going to be as consistent as obviously the roller coated process or a spray process.
Okay. So, and then the final process that we have to share today is really the hand spray process. And we do some of that, but it's not as common as what we do with some of our other processes. And there's reasons why. Typically, it's larger parts as well as it's very costly. And so there are reasons why we would use it, but then there are also reasons why we wouldn't necessarily want to use it. Can you touch on that a little bit, Pablo?
Sure. Again, well, hand spray is just spraying that by hand. Usually we have these process for parts that are large enough that won't be able to fit on a chain on edge cabin or on a deep drain tank. As you can see in the one in the picture, is a pretty large size part. So in some cases we receive some parts like that or request. Again, this is for smaller volumes. Definitely, this is a handmade process. It gives you a lot of flexibility on what type of adhesives you want to use or coatings you want to apply, because it's a pretty simple stuff. You don't waste a lot of material. Just change the pot or the gun for what you're trying to apply, and you create you apply it and you create a surface. In many cases, you also can build a tool set if you want to potentially mask portion of the area that you don't want to get covered. That gives you a lot of flexibility as well. But again, this is for very low volumes as is handmade.
Okay, that's great. So why don't we go on to just talk about really overall. So the application of primer and adhesive requires a stringent process, as we talked about. From a conclusion standpoint, really, it's the strong bond that we really want to talk about and get with our processes. And so it's absolutely critical that we follow everything that's specified, and it allows our customers to get the right parts in and be able to mold their parts properly. We talked about 6 main processes for applying primer and adhesive, and sometimes maybe only adhesive. Those processes include chain on edge, round table, which are very similar, roll coater, which are very specific to certain types of parts, dip drain, dip spin, tumble spray, which are similar in certain ways, but then also unique in that we can help process the parts better and hide touch marks and things like that. And then also hand spray, which is a much more customized option for our customers, where they can choose hand spray when parts have very specific requirements, larger than normal, or need to be masked in certain ways that we can't do with other types of processes. So really overall, the process is determined by the size and shape of the part, along with the intended use, the final use of the component. So if we touch on a part like an outer metal or an inner metal versus, say, a rate plate, where a rate plate can be fully coated in material, an inner or an outer cannot. So it's really dependent on what the customer is looking for. And so that's how we go about choosing the type of process that we'll use. So obviously there are many different types of adhesives that can be applied to different types of parts. We can do it on aluminum, steel, plastic, and other composite materials. And then also, finally, it's really important that we as a supplier work very closely with our customers to make sure in the long run that they're getting the right part and that they're getting the right bond, because ultimately the bond is one of the most critical aspects of any rubber to metal bonded part or rubber to plastic bonded part. Well, so in final, I'd like to just point you towards the Surface Engineering Academy, Pioneer Metal Finishing. On our website, you'll be able to find the Surface Engineering Academy, where you can go and find white papers, video vignettes on what we touched on, surface preparation. We even have a video on post-bonded parts, where we apply zinc nickel to those parts, as well as cleaning applications and cleaning methods for our parts. There are also other webinars that you can sign up for and also participate in the future. So we really appreciate the attendance today. We'll have a chance here for question and answer. So if anybody has any questions or answers, please feel free to answer or ask them now. You can go down to the bottom of your screen and you can type in a question at this point in time. So Pablo and I will attend or help you answer any questions at this point. And if you don't have any, then we'll go ahead, we'll send out a survey, and then you can always send those questions to us after the fact via our emails, and we'll certainly answer them in that way. What is the recommended mixing method for a 5-gallon pail of adhesive with the dip spin process? Do you want to help to answer that one?
Yeah, well, a 5-gallon pail, usually you can mix it for around 20-30 minutes. Make sure all the solids are consistent. You will know when it's completely mixed when you check the specifications of the adhesive that you have, and you usually measure it with a sand cup number 2, and when it's at the right viscosity, you will know. Usually it's around 30 seconds, depending on obviously the adhesives that you're looking for. And then for a dip spin process, usually a good dip time will be around 5 to 10 seconds to get a good film build. And then the spinning time could go probably 10 seconds.
Okay.
We're talking on this one, a 5-gallon pail. It's a very small dip spin.
Sure. So the difference between a 5-gallon pail and a 55-gallon pail, do you want to talk a little bit about the mixing time that you'd have?
Well, for the 55-gallon pail, we have a requirement of at least 8-hour mixing before applying or before using the adhesive. And again, once you finish up with your 8 hours, you take a sample, measure it, and make sure it's at the right viscosity.
Okay. Well, thank you. So we have another question that came in from Scott. Early on, you mentioned primer is not always needed prior to adhesive. When is it required, and what are the benefits of the primer?
That's a great question, Scott. Well, most of the systems work as a one-coat basis, but the primer, in studies, the suppliers have been looking at results. The primer improves your adhesion from 90% to 95%, but also reduces your cost. You know, the primer, it's usually that layer when you're molding that you're gonna burn. So primer is usually less expensive than top coat. So most of the primer, or the thickness that is right next to the metal surface or plastic surface is gonna burn before activating the adhesive. So one of the method is cost. You apply the primer, so you burn what is less cost than the top coat.
Okay, well, that makes a lot of sense. So we have a question in here from Corey. Which adhesive types companies do you typically work with?
Okay, the most common these days is Parker Lord is the one that we apply the most. We are obviously most of our customers, they dictate us what type of adhesives we use. So Lord is definitely one of the biggest ones, but we also apply. Roman has. We've had Seal Bond in the past applied as well, and currently to a couple part numbers. What's the other one I'm missing?
Well, there's Dow. There's some other.
Dow adhesives we've applied in the past as well. And again, each one of them has their own specific grade of preparation that you need to follow. So it's really important to get in close communication with your with a supplier and make sure if the process you're picking is going to be the right one, because the viscosity varies from adhesive to adhesive. You know, there's also water-based adhesives that are a little bit more harder to handle than solvent.
Okay, absolutely. Thank you. So from a complete coverage standpoint, what has better performance, dip spin or dip drain? And this question is from Ricardo.
That's another good question. Again, it depends on what you're looking for. I forgot to mention on the deep drain slide, one of the downsides of deep drain is that the dry film thickness that you're gonna get is not gonna be as uniform. It's probably the less uniform you're gonna get, because the nature of the process is gonna get you the drainage from top to bottom, and you're gonna have higher film thickness in the bottom. So if the part that you're molding, if you're molding rubber, doesn't allow you to have a high film thickness, that's definitely going to create an issue. So answering the question, I believe deep spin gets you a more uniform coating, even though there's going to be some defects due to the touch marks of the bulk process.
Okay, great. So we have another question that came in. At what stage of a new product project are you typically engaged?
Well, usually since the quotation, you know, we receive all sorts of quotations. When we look at the drawings, we look at the options that the drawing could be feasible. You know, we talk about shape and sizes. So when we look at the shape and size, if the customer doesn't have a specified process yet, we get involved and we recommend them something. You know, this is gonna give you these alternatives, and we can also quote several processes, and obviously there's going to have a price implication in each one of them, and at the end of the day it's communication with our customers that allows us to pick the right process for them.
Exactly, and I would even add to that, as a surface engineering company, really what we're trying to do is bring our customers in as early as possible so we can get engaged and help to develop that process as we move forward. All right, we have another question in from Ursula. What is the maintenance of the systems, cleaning needed for the processes? How complex? And are we ever concerned with contamination?
Well, that's another good question. Each process has its own maintenance program. We tend to clean at the end of every shift all our spray machines and cabins and purge all of the solvents and adhesives that we're using, so we are ready for the following run. So if you're switching adhesives in between runs, it's extremely important to flush everything out to avoid contamination. So when we want to schedule our production, we try to schedule as much as possible. We can using the same adhesive on one full day, if you will, to avoid those downtimes. But you can create your own schedule, and depending on what you're spraying, what type of spraying, how many guns you're using, and I'm talking chain and edge here because it's one of the most used systems, you need to determine how often you have to clean. There's also sensors inside of the cabins that tells you when it's need to clean before causing a potential fire, because that's one of the biggest issues. It's not the contamination. You could cause a fire if you don't clean your cabins and your tooling.
Exactly. And so here at Pioneer, obviously safety is a critical aspect of things, and we want to make sure that everybody is safe as they go forward and work in our plants. And not only that, but we also want to make sure that you're getting a good part. Okay, thank you. So we have a couple more here. What precautions do you take for packaging and shipping? And that one's from Oliver.
Hey, that's a good question. It all depends also, again, we have different ways of packaging. The most common, or what we need to make sure, is usually we set up a bin liner, a plastic bin liner, completely clean, brand new, on the parts that we're gonna put inside of a box. Call it a small box or a large box. There are customers that require smaller boxes, tote packaging. We can do that. Also, there are certain parts that require special handling. They don't want bulk packaging, so we need to accommodate, put cardboard layers in between in case it's a specific request from our customers. So it all depends on what the customer is looking like, but at the end of the day, you just need to make sure there's a clean surface you're putting the parts to avoid contamination, and when you're completed, you completely enclose that. You make sure also that the parts are not hot or warm, because it could create condensation inside the bag. So usually we put cardboard on top, and then we ship it to the customers.
Yeah, and that's definitely something that we need to watch out for as parts are being shipped across the country, or from Mexico, for example, to the U.S. and vice versa. That it's critical that we watch out for that, for heat and humidity that gets built up. And so whether it's a VCI bag or some other humidity controlled device that we use, it's important, because that could damage the adhesive or primer and cause problems ultimately with the bond. So I apologize. I actually said Oliver, but it's actually Olivier. And so he or she has another question. So what is the shelf life of the adhesive once applied?
Okay, this is another question that is kind of open, and my best recommendation is to talk to the vendor who makes the adhesive. But for example, Lord usually has 8 weeks for their adhesives once they're applied. Obviously, you need to have take good care of the parts, being inside of the building with no humidity or contamination around, in order to provide those 8 weeks. But I've seen some other customers that they don't like to wait that long, and some customers usually have 4 weeks set as their due date for those samples. But it all depends. In my experience, I feel good with 8 weeks tops, and after 8 weeks, if you want to use them, I will recommend to do a trial before using mass production. And if you do that trial and the parts perform the way you're looking for, you can probably continue with that. If not, you can send them back for rework, and the rework can be just as a light spray with a very low viscosity adhesive, the same top coat obviously, and that will activate again the adhesive, and you will have a good performance.
Obviously, that all needs to be tested out and defined, right, prior to using for production, obviously. Yep. Okay, so next question. What are some of the advances in rubber to metal bonding technologies that you are working on that we can disclose anyway?
Well, that's again, what we've seen in rubber metal bonding, it's nowadays, most of our customers are looking to move into different type of surfaces to bond. You know, we've talked about the plastics, about aluminum parts. Customers are looking to build lighter vehicles, and that has been one of our challenges. How can we apply it into plastic? Definitely one of the biggest challenge we've seen in the past 2 years, it's how to apply coating on a metal surface that is already plated. And again, we've been talking to Lord in most cases, because this is pretty new request over the last couple of years for many customers. Either apply the post bonding, as we call it, the plating after the parts are already molded to prevent them from rust, or apply the adhesive on a plated surface before molding. So those are, both of them are good, but they require a lot of attention because we've seen some potential debonds in both of them. So Lord is working on how can we determine the specifications for a plating surface to apply the rubber on.
Exactly. I mean, if you think about it, as aluminum and plastics become more and more popular, used more and more, we start to see where it becomes even challenging to try and utilize those components in rubber to metal bonded parts. I think the other thing that we want to touch on is the increases in vehicle life, right? And as vehicles get older, those corrosion protection requirements become even more important. So the types of materials that are being applied after the part is bonded, and so can the bond hold up to those? Can it resist the corrosion defects to them? As well as, like you mentioned, Pablo, what materials are being applied to the components so that when we coat the part, are we ensuring that it has a good bond all the way through the process? So exactly, I think those are very good points to make. So we have another question from Casey. What devices are used to mix primer and adhesive?
Well, usually here at Pioneer, we use pneumatic agitation in all our drums. All our machines have pots already included with that, and they are constantly mixing all the time. We mix them at a very low RPM just to maintain the solids moving and make sure the mixture is consistent. We use pneumatic here.
Yep, absolutely. Okay, how do you evaluate the performance of the bond?
Well, we actually don't evaluate the performance of the bond. That's what our customer do. Once they mold the parts, they perform bond tests, destructive tests, and they make sure the bond is what they're looking for. Usually it's over 90% adhesion, what they're looking for. In our case, just to warranty quality, obviously we have different controls among the processes. Make sure we are applying the right cleaning. If the right cleaning out of our phosphate lines or out of our blasting areas, the right surface area, we have technology to measure those items. And then we measure the film thickness. At the end of the day, that's what we want to do. We want to apply the right film thickness on the primer, the right film thickness on the top coat. If we can warranty those items, we are pretty confident that the parts are going to perform the way they're supposed to.
Ultimately, it's the part and how it performs, and that's what's critical about our process. Yep. So what about barrel coating? Do we do any of that, and is that really a part of the bonding process? And I would say, go ahead, Pablo, you can answer.
We're not that familiar. I've seen a couple barrel coaters in the past. One of our customers, SKF in Guadalajara, they have a barrel coating, which is basically just as our phosphate line, but instead of putting the last step on the process after phosphate, could be a seal or organic seal, they put a water-based adhesive by barrel, which is going to be pretty similar to dip spin. It will be in a bulk process. The parts will get coated with the adhesive at the end of the phosphate line, and then they will come into a drying station, and then they will proceed. We don't perform that at Pioneer, but I've seen it in the past. It's pretty similar to dip spin.
Okay. And then one last question, and then we'll let everybody go. What type of solvent are you using?
Okay, this is another good question. Also needs to do a lot of what is the type of adhesive you're using and what is the recommendation from the supplier. But for primer, usually you want to use a solvent that fast evaporates. As mentioned, it's very important. So usually we use MBIK or MEK, which is a very good solvent and fast and evaporates really fast. And for top coats, again, you need to make sure what type of what is the base of the adhesive that you're using. You want to use something that is compatible and pretty much the same. Most of the cases, the Lord adhesives that we use have toluene, so we use toluene. But again, they're not rule. My recommendation is to check on the data sheet of the adhesive that you want to use. Talk to your vendor and supplier, and try to come up with the best solution because it varies.
All right. Well, thank you. So very, very active question and answer session. That was really nice, and I enjoy all the different questions from our customers. So appreciate that, and thanks for your help, Pablo. Hopefully you've enjoyed our webinar today. And like I said, you can always go to our Surface Engineering Academy website on pioneermetal.com, and you can find different webinars, opportunities for joining the future ones, as well as reviewing some of the past ones. So we'll go ahead and let everybody go. Have a great Friday, and thank you very much. Appreciate it.
Thank you very much, everyone.